Oh, thank you, Roy. Okay. All right. Great. The recording will be uploaded to the website. Um. Uh. At most tomorrow, I guess. Yes. So you will see on the website. You will see on the QC learning common website. You can go there here, and then open the chat. You can go there here and go to resource. Go to CSCI resource. Scroll down 111. Then it will be replaced right here. Okay, recording will be uploaded here. And yep, let's start it. So the topics are function and array. So including 1D array, 2D array, and then recursion. And in general, the output question. Output question include like all things that you have learned so far. But this output gonna be the easiest one. So yeah, okay. So for the function, okay, let's talk about function, please. For the function, you guys see the VS Code that I'm writing? Yes. Okay. Thank you. So in the function, what you need to know is the first part is yes, program design will be on the exam. So program design will be like write a function. So you need to write a function. Also, the accurate exam will be on the paper. Yes, the accurate exam will be on the paper. So I will not use anything other than like text editor, so like txt. I will just use txt to write all the code. It will be on the paper. So okay, function. So function has three main type. First is return type, and then function name. And then in the parentheses, these are called arguments. Okay, argument can be more than one. And this will be the function title. Okay, function title. In the argument, okay. So let's break it down. So let's talk about return type first. The return type. So can you tell me what types of return type is it possible for here? Integer, string. So yeah, string. What else? Double. Char. We have more. Anything else? Why? So we have, I think, one more. So that will be float. Float is the same as double. So usually you will not see float. Like float is the one of the possible. Okay, so I will add a float here. So usually if you need to return like a decimal value, you can just return the double. You can just use the double. Okay, when do we use the void? When do we use the void? There's no return type, correct. So usually when you use the void, usually you pass by reference or you just want to print out in a function. There's one use the void, mostly. All right, so there's a return type. Function name is the easiest one. I'm not going to explain about function name. Let's talk about arguments. So arguments, you need to, argument can be more than one. It can be like, there can be no argument too. So when you write argument, there need to be like data type of the argument, and then the name of the argument. So when you write argument, you need to be write like in this format. Okay, so talk about when you talk about the data type. It can also be array. Okay, it can also be array. So when you want to pass to the array in a function, you're gonna receive, like, for example, integer array. You're gonna receive, so this is integer 1D array. So you need to receive like this in your arguments. Okay, in your arguments, when you pass the array, you need to write an argument like this. This is for 1D array, right? And then how can I pass 2D array? Okay, but before I pass 2D array, let me clarify one thing. So the 2D array will be, let's say, I have integer 2D array, 2D, let's say 2D, that I have rows of 5 and columns of 3. I have a 2D array like this in my main method. So how can I pass this 2D inside the arguments? How can I write here? Any guess? Yep, that is correct. So when you write, yeah, yep, that is correct. So the name doesn't need to be matched. You can name any name. So first you can name any name, and then okay, let's name anything. So it can be like array AR2, and then the first you don't need to put anything, but the second, which is about the column, you need to be specified. You need to be same as the one that you're going to pass. So this is going to be 3. Yes, so this is for 2D array. Okay, and there's another thing called pass by value and pass by reference. So pass by value is just the same. Like I can pass like in I or something like that, in A, something like that. So if I change those values inside the function, it will not change in your main method. However, if I want to pass my reference, I need to add the ampersand sign, right? Ampersand sign before the name of the variable to pass as an array, sorry, as a reference. Okay, so for 1D array or 2D array, you can write this bracket before the name of the variable, or you can write like in ARR bracket. These two are the same. Okay, the order doesn't matter for the array. Even though the 2D array, it doesn't matter as long as you include the bracket, right? So I think mostly we write like this, right? So you can just write like this here. It will be more clear to you. Okay. So now you know about pass by reference, data type, name, arguments. Arguments, and so on. So I think we can start doing the function signature. Does anyone has any numbers for function signature?
Maybe we can go over the first question. I'm not sure.
The first question?
All the way up, I think.
This one?
No, the one where. Yeah, you can do the first question.
The third question?
First one.
Oh, first one. Okay. I will do like 2 or 3. Okay. Okay. So the first one, all right. So we have a string, we have a 2D array, we have array, okay, and so on, so forth. Okay, and then right here, and then let me write it here, and then here, first letter, name. Okay, let me ask you. Before we talk about the function, return type, what is the function name? Okay, I know what the function name. Function name is first letters. Okay, what is the arguments? Can anyone answer? Name is string. Here's a name. So in the variable. So we look at the name here, and then there's a string. This name needs to be string. That's the string a comma name again. I put it again with string b. You don't your name, the name of the argument doesn't need to be matched. It is okay if you use the same thing, it is okay, but you cannot use like string A and string A. You cannot use like this. You need to be different here, but you don't need to be like use it the same again. Okay, so what is the return type? It's that it print f. What is the return type should be? It prints, so it could be string, yes. So there are two reasons this could be a string, and this is not char. There is also one reason. So whenever you see the number, the character, you can just say string. And then or char, you can say char or string. But look at this, it print 3 letter F space and F. So char can only hold one character, one letter, or one space. It cannot store like 3 letter or 3 character. So it cannot be char. So we need to use the string. Okay, so this need to be string. Okay, why not 5? 5 print. Okay. That's a good question. So, yep, why also print inside the function? But here, look at this. See out. I'm printing here. I'm printing in here. So I want to. So which means I need to return something here to print it here. Okay, that is why you need to return the string. Okay, so you will see here we are not printing anything. So this is highly possible that we can use y. But whenever you see the cout like something like this, you're gonna need to return something to print like this. Okay. And then okay, does the question one start from the specified value? Does the question one start from specified value, specified reference? Doesn't matter. It doesn't matter right now here. Okay, we will talk about later for the specified reference. Later, but like for this question, no, you don't need to. You don't need to worry about the specified reference or specified value. Okay. So the line D is Y because there is no cout. We will talk about that. Okay. Okay. All right. So let's move to next one. So this is question number 1. This is for A. Let's do about B. Okay. Okay, let me just write the name. Stem off. Okay. How many arguments are there? 4 arguments. Okay. Wait, can anyone tell me the answer? What did the type n? How can we write in the arguments? A is 1D array, int. Okay. Okay, so since A is like 1D array, how can we write? Yes, that is correct. It will be int A with a bracket, and the next one is 5. 5 is in B. Okay, the name need to be different. Remember? So to make it clear, I will just use let's say A, and then L, and then A again. So this is a array. So in LM, LKLM, in N. All right. Make sure you use the different letter for each argument. And then what is the return type? What is the print? It prints 68. So what is the return type should be? Integer, correct? Right. And then for C, wait, one second. Okay. So another one is middle initial. So what is the name? We already talked about it. It's a string. Let's say n. And then what is the return type? It only print n. So what is the return type should be? The char. Right now it's char because it only print one letter. Okay, but like if you print string, do you think it is correct or it is wrong? If I replace with string. It's correct, okay? So this can be char or this can be string, okay? So there are two possible answer right now. For now, there are two possible answer. Let me write down here. One can be string, one can be the char. These two are correct right now. Okay. So you see the n. So n can be okay. You see n. So this one character. So you set it as char. That is true. But if you this since it's like a letter or something, when you put a string, it is not wrong. It's still correct. Okay. However, we need to check here again. Okay. So before we go here, let's do this one. You will see why one of the answer we cannot use. Sorry. Oh my God. You will see why one of the answer is wrong when we reach this part. Okay. Let me move on to D really quick. So it's we don't need to return anything. There is no CL anything. It just reset the array with random entry. So you can just say void make random and then the A2. What is A2? A2 is the 2D array. So how can we pass the 2D array? No, A2 is not integer. Yes. So I mean yes, the data type is integers, integer array. So it will be int let's say A with bracket and bracket 3. Don't forget the 3. Okay. In 2D array, you need to pass the column numbers, the numbers of the column. All right, so this is how you pass the 2D array. And then the other is easy in B and in C, because here is just 2 and 3. All right. Okay. Number E is a little bit tricky. Okay, let me highlight. First, when you see this is we call it like a nested function call. So for the nested function call, what we need to do is we need to see the innermost function. Okay. Okay, let's see the innermost function. Oh, the middle initial. We're done. Okay. It can be string or it can be char, we don't know. Then when you look at the like use the different one. Okay, so when you see this count in is this whole thing up to here, right? So count it include two things. We don't know the return type yet. Count it. So the first one is it can be char or it can be string. We don't know yet, so I will put it like this. Okay. We need to get rid of the one of the thing. So it's not unsure yet. So just put like this. And then yeah, 5.0 is double B. Okay. Okay. So this is good. So however, when you look at the outermost here, count it. It called the count it again. Okay, so this is one, and this is like here. This is your another. I believe here. So it will be like this. So count it. Call it again. Count it outside of the function, the outermost function call, and then what you will see is the first argument is name. Oh, so what is the name? Name is string. Okay, so count it. The first argument is string. So if the count is the first argument is string, this cannot be char anymore. This need to be string. If this is string, you will see count it the first arguments. Okay, it cannot be string. Sorry, it cannot be char. So the middle initial return type need to be string. It cannot be char anymore. It must be string because you see the count it has a name. The name is a string. So count it. This must be string. So the middle initial must return string data type. Okay, so we cannot use char anymore. The answer will be string. Okay, and then you will see count it. We have the first argument is string. What about the second argument? Second argument is double. So since you look at the outermost function, the first is string. The second is what? Okay, we don't know the second. So look at the inner function again. Count it. The first is string, and then the second one is double. So the first is string. This second one need to be double, which means the count it must return double. Okay. Does anyone understand this count it part and how I get rid of the char return type for the middle initial? Or any question with that before I move to make random? Okay. I will wait the response. Does anyone understand the count it part? I get the double return type and I get the string return type and not the char. Clear. Okay.
Yeah, sorry. Can you explain the difference between char and string again? Because I'm still confused when to use string or char. I thought if there's only one letter, that means the character, but if there's multiple, it's the string. It
is correct.
Clarify it.
That is correct. What you just said is correct. One character is for char. Multiple character is for string. That is correct. And I talk about that. So char is okay. One letter. Oops, one letter. String is 0 or more letter. So which means like string can be greater than or equal to 0. So greater than or equal to 0 means it can be 1, it can be 2, it can be 0, it can be anything. So, for example, we say A, we can put A in the single quote, or we can put A in the double quote. This is a char A, and this is a string A. Okay, so string is like more flexible than char. And I think you're confused about, so whenever you see the one character, you must use char. No, you should use char when you see the one letter, but you can also use a string. Does that make sense?
Yeah, because I was still confused about C. Line C.
Line C, the return type string.
Yeah.
Yeah. So for this question, like I say, so n, so you said it is char. That is not wrong. That is correct. However, when I see this count right here, the first argument is name is string, so this must return the name. This must return the string. Because string can also represent one letter. That is why we cannot use the char. But let me ask you again. Do you understand about difference between string and char?
Yeah. So I kind of see that char had one quotation and the string had two quotation.
Yes. Yes. For example, AB is not char. AB must be string. Okay. A and B are or string. All right. So, but like you need to confirm with others like lines so that we can use it again. Okay. And yeah. So the reason here is double is 5.0 is here double. And then you see the outer count in. So the count in the first, okay, what is the first argument need to be string, and this is the second argument. So you can see we don't know the second argument, but when you see the count in the same function, when you see the inner count in, the second argument need to be double. So this second argument need to be double, which means the count in must return the double. Okay. Okay, so what is make random? What do you mean what is make random? It is a function. I don't know what okay, it does like reset the array with a random entry, but we don't need to know this like what it does. We only need to know what it passes and then what it should return. Got it? Red D. Okay. All right. Okay, we can do. Okay, so yeah, this is for function signature. Okay. Okay. Let me move to the. Okay. Let's review. Do you guys like any question for the function signature? Which means, do you guys have any question with the title line? Because I'm going to move to next topic. Everything good?
I have one question.
Okay.
So when should you for char it's one letter, right? And string is either zero or more letters. So when should you, I guess, know when to use either or?
Okay, good question. Um, so I think in the test, he like for like even on this question, like you cannot use char because like you need to like check again. So I think in the test it will be clear. Let's say for example like you call this function. Okay, we don't we it, you, okay first you think okay it can be string or it can be char. We don't know. And then in the next sentence or like something like that. For example, let's say okay. Okay, forget about this line. Okay, right now we are in this line. So and then after that line, no, on that line, I will do like char x will char x, and then x equal middle initial in the string name. If I do like this, the return type must be char. So we need to clarify with the other entities. However, if he doesn't like ask question like this again, which means if you don't need to check again, you can use either one. It doesn't matter. You will get full credit for that because like there's no specifying that this is string or this is char. But like in this question, this is specifying. You must use the string. So in the test, if he doesn't like clarify like on the another line, either is fine. Got it?
Okay, thank you.
Yep, no problem. Okay, now let's move to another one. Before that, whoever just joined the meeting, make sure you fill the attendance form. Okay, that can help us to do review session in the future. All right. Not only the final, maybe like not only the final, but also like other 200 level class too. So if you see next semester doing review session like this, you make sure fill out the attendance form, right? Okay, let's move to next one. Okay, do you want to go to program output or do you want to go to the program design? Which one do you want to go first? Program output. Okay. All right. Okay. Output. Okay. 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 First question. All right. Okay. After first question, if anyone has like a recursion output, we should do that here. Well, the recursion output is a little bit difficult than the normal one. Right? So if anyone found the recursion output question, please put in the chat. So I will do next one. So let's do the first one first. Okay. So this is the function. So right now, we don't need to worry about too much first. Okay, do you guys see this like bigger one? You guys see the screen still? Yes, okay. Okay, so here, this is a function. We don't need to worry about that. This is okay. We have 1D array, 1D array. Okay, let's look at this line. What is y index of 3? What is y index of 3? 7. 1, 0, 1, 2, 3. 7. What is 7 mod by 7? 0. That is why the output is 0. Okay, let's do next one. Oh, we have the nested like calling array. So whenever you see the nested, look at the innermost one. What is x1? X index of 1. 0, 1 is 3, correct? So you can replace with 3. And then y index of 3. What is y index of 3? 7. Good. Okay. Now, this part. We call the function f. The first one, we pass the x of 0, which is 4. You can write 4 here. This is 4. And y0 is 2. Oh, there's an ampersand sign, which means this is passed by reference. When is it passed by reference? Whenever you change in this function to the y, what is y? y0. y0 is this place. Whenever you change the value of 2y inside the function, you will change the value. Okay. Okay. I will say that again. Whenever you change the y value inside this function, you need to change the y value. Sorry, you need to change the y of index 0, like in this here, number 2. All right. So x equal x plus 1. So what is x? X is 4 plus 1. This x is 5. Correct? What is y here? Y is 4. If this y is 4, we need to change y here. Okay. Yeah, this y is 4. So is this y is this place 2 become 4? Yes or no? Yes. Yes, 5 minus 1 is 4. Correct? That is correct. So, and then x is 5. So 5 minus 1 is 4. Y is 4. If this y is 4, this y also 4, which means this y also 4. And what is y0? Y0 is 2. So this 2 became 4. This 2 no longer exists. This became 4. Okay? This became 4. All right. So y0 is now 4, but x0 is still the same. That is correct, because x0 is passed by value, y0 is passed by reference. Okay, and then, so y is 4, x is 5, x plus y is 4, 5 plus 4 is 9. So we return 9, that is correct. So you need to print 9. 9 is here. Got it? Okay. Okay, so another one. So y0, what is y0? 4, that is correct, good. What is x0? x0 is 4, so you need to print 44. Okay. All right, so let's see the last one. So when you see like the nested like calling function or something like that, look at the innermost one. Let's look at this one. You call the function f x1. What is x1? We delete this again. x1 is 3. Okay, x1 is 3. So it plus 3 here. What is y1? y1 is also 3. y1 as by reference. When you change here, you're going to change it here. Okay, so let's look at this. So after this line, x become x is become 4. After this line, y become, it is not 2. X is 4 right now. 4, x is 4 right now. This is 4 right now. If this is 4, 4 minus 1 is 3. Y is 3. Oh, it's past my reference. Y is 3. I need to change. Look at the y1 again. y1. Oh, it stayed 3. But like so the value is the same, so we don't need to change anymore. If the values are different, we need to change this number. And then 4 and 3, add them, get 7. So this one, this, then will become 7. Okay, so it is calling f of 7, comma x of 2. Okay, it is calling like that. We need to call the function again. All right. When you call the function again, so x become 7. x2. What is x2? What is x2? 2. Is it 2 as my reference? Yes. So whenever you change here, you don't need to change here. Okay, let's see this. X is 7. 7 plus 1 is 8. So this x become 8, correct? Do I need to change here to 8? No, no, no. Okay, we don't need to change. The catch is here we use x, we use y. But doesn't matter. The name doesn't matter. The first is 7, the second is 2. This second y is x2. This I change the values of x, which is 7 here. This is 7. Y is x2. Right? This x doesn't mean this x. It is completely different. And then here, what is this x? This x is 8. 8 minus 1. Y is become 7. So if y is 7, do we need to change here? To 7, yes. So y is here. As my reference here, when we look at it, x2. Oh, we need to change the x2 because the value change here. We change it to 7. This is no longer 2, this becomes 7. And then you add those two, you will get 15. Okay. And then change to 15. Sounds good. Clear the first screen. Clear the screen first. Okay. Okay. All right, let's do it again. I will do quickly. But you gotta answer when I ask. Okay. Let's do quick. So whenever you do like a nested function, look at the innermost one. What is x1? Okay, I need to clear out this one. Okay. X1 is 3. All right, x1 is 3. So x1 is 3 here. Y1 is 3. Y is it y1 plus is y plus y reference? Yes. So if I change the value of y, is the y1 here? Does the value will change? Yes. Okay. So x is 1, x is 3, 3 plus 1, you get 4 here. All right. So the x is 4. And then y, since x is 4, what is y? Y is 2. Y is not 2. Y is 3. Okay, y is 3. Okay. Do I need to change anything? Okay. Okay. So, and then you just add them, right? Get 7. Return 7. Correct? Why is it 3? Because x is 4 here. X plus 1. X is 3. Put into here. This x is become 4. I use the x again. X is now 4. 4 minus 3, I get 3. Okay, I add the x here. And then I reuse the x. Okay, good. So I return 7. When I return 7, the whole function, this whole function, return 7. So this whole function become the value 7. Okay. Did you make up the number x equals 4? No, I did not make up numbers. You see here, x is 3, y is 3. Where's x here? X is 3, right? X 3 plus 1 is 4. I got 4, put into x. Right now, x is equal to 4. And then I need to use x again. What is x value? Yes, you can speak.
I just don't understand. Why did you find 3?
Sorry?
Like, why did you get x equal to 3 and y equal to 3?
Oh, it is from here. What is x1?
It's 4, or like x 4, right?
Okay. Let me ask you, when you like assess the array start at index 0 or 1?
0. Oh, yeah,
0.
yeah. Okay, yes.
Right?
Okay.
0, 1, 2, 3. x1
Okay.
is
1.
x1 is 3.
Oh, sorry, yeah. X1 is 3.
3. Yep, that's why you get 3 here. And then you got it right. And then keep going. x3 plus 1, x became 4. 4 minus 1, y became 3 here. And then x plus y, I got 7. Got it?
Okay.
Okay.
Yeah,
Mhm.
I'm just thinking that why do you have to pick like x1, not like x2 or 0?
I mean, why I pick x1?
Yeah.
Because the
Oh, sorry,
question
here.
said x1.
Okay. I'm sorry. Okay. Okay.
Okay, the question said y1. That's why I pick one, y1. y1 is 3.
Okay. Got it.
Okay?
All right. Thank you.
Okay, no problem. Okay, so so this f became, so I just returned 7. So this f, okay, no, don't erase it. So this whole thing became 7, which means after I return 7 comma x 2. Okay? Okay, let me read. Isn't the x in the function not the type x? We are using the x in the function, not that. Okay. 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 All right. Okay. Let's move on. So we're here, right? We need to call the function again. So the first is 7. So x became, this x is 7. What is y? 0, 1, 2. Yep. Y is 2. And then x became what? And after this line, x became 8. After this line, what does y become? Y became 7. Y value change. So what value do I need to change? Array x, correct. So since y is passed by reference, which means x2 is passed by reference, whenever you change the y, you need to change the x2. x2, 0, 1, 2. This become 7. Good, correct. And then we can move on here. And then x plus y. What is x plus y? 15, right? So this whole function return 15, which means the whole function return 15. So the output will be 15. Got it? Okay. Do I need to explain that line number 1, line number A? I think Olivia already explained. How do we know which one we need to change? Okay, so how do we know? As you can see here, X, we pass that array X, that's by reference. Okay, so array X, that's by reference. That is why we don't look at this Y. This Y make you confusing. You only need to look at, okay, first and second. This Y doesn't mean this Y. No. Okay. This Y is just the name, just the variable inside this function. Yeah, the ampersand makes you to change inside the array. So, okay, so the question is, if you don't know what one you need to change, you need to look at what value, what variable did you pass. You pass the X to, so you need to change the X. If you pass the Y here, you need to change the Y. Okay. Okay. All right, let's do similar problem. Do you guys want to do this, or do you want to do another problem? Do question 3. Okay, let's do question 3. Yes, this has recursion. This has recursion. Yeah, CS recursion. So yeah, this solves every question. Okay, let's do this. Let's start line A. We need to look at this one first. What is y mod z? Y is 3, z is 4. 3 mod 4. 3, 4 here. What is the remainder? Wow, hey, okay, how do you get 1? Yes, it is 3. 4 times 1 is 4. You cannot do it. You get -1. All right. So 4 times 0, 0, get 3. So the remainder is 3. Okay. In the test, just divide it. This may you confused because it's 3 over 4. It's not greater than 1. Okay. That's why it is 3. Okay. So this is 3. So what is 1, 3? Sorry. What is x3? Yep, it is 4. That's why it print 4. Okay. All right. Okay. Oh, function call here. Okay. Pass the x and pass and y. X is the array, y is 3. Okay, let me ask you. Is the array passed by reference or passed by value? It is not passed by value. All the array by default passed by reference. Okay. All the array are passed by reference, which means if you change something in here to the array value need to be changed. Okay. So let's do this. So So this is like X array. So this is this array. Y is 3. This Y is 3. So this is passed by Y is passed by value. So you don't need to worry about anything. Just use the Y. So here, X0 equal Y. Y is 3 going to X0. So this X0 became 3. Does it make sense? Does anyone understand why this became 3? Okay, so here Y is 3. Okay. So here Y is plus 1 value. So Y is 3. 3 is here. So array are passed by reference. So whenever you change to the array, so you change the array index of 0 to 3. Whenever you change the array here, you need to change the array here. It is connected. It doesn't, so you can see I draw the arrow, right? So I draw the arrow, which means if I change something here, I need to change here. It doesn't copy like a new value. It's just that this x0 mean this one. It's directly connected. Okay. So in this problem, yeah, array are passed by reference, always passed by reference, always. Okay. So you pass the array here. So I receive, you see x with the bracket. So this is array. So I change array index of 0. Array index of 0 is 1, right? However, this one place. So y is 3. Okay. So I put 3 to the x place of 0. So the original one is like this. And then you change to x0. x0 equal to 3. You set the value to x0. What's x0? You look at here. Oh, look at here. And then x0 is 1. So we need to change to x0 to 3. Okay. This is pass by reference, meaning that pass by reference is like reference like an arrow, like this. We need to change like this here. Yep. Okay. Okay. And then I change to x1 is 2, y equals 2. Y became 2. Y became 2. But y is passed by value, so it doesn't need to change. Okay. You update the array whenever it is passed by reference. Okay, I will tell you again. You update the array whenever whenever the array is passed. Whenever the array is passed, when the array is passed like this, you always need to update your array if the value is changed. But it is always passed by reference. Like when you pass the whole array, you need to change that array. Okay, we have like B here, so we can like explain more here. Okay, let me delete it again so it makes you confused. Yes, I will show the function B. Function B is like pass by reference. Like pass by reference mean like both are pass by reference. This is by reference, this is also by reference. So this is like by reference, by value. Okay. But I cannot change 3 here. 3 is stay here. I change in the function A. So when I print it, x0 became 3, and then y is still 3. Right? It doesn't change. Okay, let's look at function B. You are more clear when you see the function B. X is here. So it is array, the pass by array. So this X is this array. Okay. And then Z
Sorry.
is okay. Question?
Yeah. So I just want to understand. So you said x0 is equal to 3, right? It's because it says x0 equal to y and y is equal to 3, right?
Yes, yes.
Okay. Thank
That is
you. I
correct.
just wanted to make sure.
Yep, that is correct. Yeah, y doesn't change because it is passed by value. See, I don't have any ampersand sign here. Right. Okay. Now I see the ampersand sign here. When I pass the value of z. So let me draw the line here. Ignore y equal to 2. What do you mean y equal to 2? We don't, y is not 2. Y is 3. We don't have 2. Oh, I see what you mean. Yeah, we can ignore this line. Yeah, so y value change, like y value change inside the function. So y became 2. Y became 2, but it is stay inside the function. It doesn't affect here. Okay. So these letters, you see this y, this y, this x, it can be anything. So because like you see, I pass a z, but the name of the argument is y. This y doesn't mean this y. This y is now I pass a z. Pass it here. So the next time we go to the function a will be no. After you call the function like here, like it's done. Y is like no longer 2. Y is nothing. It's like the function is clear out. That's why I delete all of them here. Right? After you call the function doesn't have any value. Next time you call it, it will be like new value. The array doesn't need an n%. Yes, the array doesn't need an n%. It is always passed by reference. It doesn't pass by value. It never pass by value. It is always passed by reference. All right. So, okay, so B is here. Are you talking about line B or line C? Is it 34? No, why is stay 3 here? Why is 3 here? Why is 3? What do you mean 34? How do you get 4? 4 is Z is 4. Yeah, this is Y. We are talking about line B, not line C.
So you know how it says after the n line, it says b and then parentheses x equal to z.
Right? This doesn't relate to each other. So line.
It's not.
Oh, you are talking about function B. Okay, my bad.
Yeah.
Okay, we don't know yet. Okay, let's see. We don't know yet. Okay, let's see. So Z is passed by reference. So Z is 4. I pass it here. Okay, let me delete it here. Okay, so this X is this array. This Y is this value. Okay, so Y, I look at Y, go to the arrow here. Y is 4. This Y is 4. And then X2 is 4. So X2. Okay, X go to X, do X2. 0, 1, 2. So this 3 become 4. Okay. And then go to next line, X3. What is X3? You go to like this, X3, 0, 1, 2, 3. X3 is 4. So you go back. So X3 is 4. And then Y equal 4. Y became 4. So Y equal 4 is assign a Y to 4. Y is 4. So I go there, Z. Z stay 4. right? So we don't need to change. And then in the C out, I print out x2. What is x2 right now? It is 4. Good, good. What is y? Oh, sorry, what is z? Z is 4. That's why it print 44. Got it? Okay. Okay, before I go to the recursion, Roi, can you do the part of recursion?
Yeah. Do you want me to just continue off where you left off?
Yes, yes. This two line.
Okay. Thing is, I can't edit your PDF.
Yes, you can make a new one. So I will send this PDF. You can make a new one. You can continue.
Oh,
that.
1 sec. Actually, 1 sec, Mike. Do you see
But
that?
oh yeah.
Okay. So I guess I can edit it. Okay, fine. Give me 1 second.
I will just
Okay.
do like this.
Okay. So Mike, you update everything. Okay. So now we go to function void C. So we're over here. Let me do it in blue. Okay. We pass in the entire array x and the value 4. So we see, is 4 less than 2? So it's not. We move on to the next line. We print out x4 plus 1, which is x sub 5. X sub 5, according to this question, is going to be 6. 0, 1, 2, 3, 4, 5. So that's 6. Good. So we print that out. And then what we do is we go to the next line. We do the call C, the entire array x, and we plug in 2. Okay. So we check, is 2 less than 2? The answer is no. So we move on to the next line where we print x sub 2 plus 1, which is x sub 3. X sub 3 is 0, 1, 2, 3 is 4. So we print that out, that's 4. Then we do the next line. We say C of x comma 1. 2 divided by 2 is 1. We check, is 1 less than, is 1 less than 2? It is, so we return. Return just means go back to where it was called. So that's it. 64 is the only thing being printed out there. Does anybody have any questions about that? Okay. So let's move on to the next one. Now we're doing a for loop. We have a for loop. We start at the value of 0. Just 64. Yes, just 64. Okay, so we go into the for loop and we have I equals 1, I is less than 4, so we know we have 0, 1, 2, 3. We have 4 iterations, and we're going to do it based on Cx, and our second parameter, our second argument is always going to change. So let's do this. We have x0. Okay, let's see. So the first line, let me erase these also. So we plug in x and 0. Is 0 less than 2? Yes, it is. So we just return. Great. Nothing to do there. Cx1. Same idea. Is 1 less than 2? Yes, so we return. Now let's do the next one. Is 2 less than 2? No. So I print. Correct. Nothing actually returns. Exactly. So I print, let's see, x sub 2 plus 1, which is x sub 3. X sub 3 we said was 4. Okay, so we print out 4 so far. for line E, we print out 4. Okay, then I do the recursive call C of x comma 1, which we already did before, and we saw nothing comes out of it. So we go to our next call in the for loop, C of x comma 3, right? Because I was 2 last. This was what we call a recursive call. So I is 3 now. Let's check. So 3 is not less than 2, so we print x sub 3 plus 1, which is x sub 4. X sub 4 is 5. I put a 4. 5. Excellent. Now, we do the recursive call again. We divide by 2. Now, C of x comma 3, what's 3 divided by 2 in this case? Does anybody remember how to do integer division? Exactly. 1. Good. Okay. So it's 1. So this is really just C x comma 1, which does nothing. Because we saw when y is 1, 1 is less than 2, we just return. Okay? So your should be 4, 33, 44, 64, and 45. Does anybody have any questions about these?
Can you explain C x dot 0, x dot 1, and x2 again?
What happened? Sorry.
Can you explain how you got C x dot 0, x dot 1 to x dot 4 again?
Yeah, so right down here you have that for loop where I is changing values. I is 1, then I is 0, then I is 1, then I is 2, then I is 3. I is going to be our second parameter, so that's why it's always changing over here. It's always changing over here. Does that make sense? Can you explain A and B? Mike, somebody's asking if you can explain A and B again. You know what? I'll take over for it. It's fine. No worries. Okay, let's see. Okay, sure. Let me just erase everything here. Okay. So, somebody wanted to go over A and B. Let's do it. So with A, you're doing X mod and then the values of Y and Z. So Y is 3 mod and then Z is 4. Okay. Now the way you do mod is, so let me rephrase. The way you do integer division is you take the number before the decimal. Mod gives you that decimal. Okay, so it'll tell you the remainder that's left over. So in this case, the way you do mod, so mod works but with this way. Did I do this correctly? Yeah, 3 mod 4. Good. 3 mod 4. So you see, the second number goes outside, and the first number goes inside, right? The way I remember it, the first number gets the house. Think of the division sign, the division symbol as a house. 3, and then the second number stands outside. Okay. You ask yourself, how many times does 4 go into 3? And the answer is 0. It doesn't go into 3 at all. 0 times 4 is 0. And you're left with a remainder of 3. Okay? So this one would equal 3. And then you check the position. What is the position of 3 in the array? So we know arrays start at 0. This is 1. This is 2. And this is 3. So we get 4 as our answer. Okay? Hope that makes sense for A. For part B, then we have to do this function call. I don't know if it changes something again, but let's see. We do this function call. a of x comma y is 3. So we have x and 3. And so x sub 0 equals y. So now this is a 3. And then y equals x sub 1, but that's not passed by reference. So we don't need to change anything in the main function. Okay, now we do b. B says C out x sub 0. So we just changed the value of x sub 0 because of function a. So that's a 3 over there. Then we print out the value of y. Y is also 3. So it prints out 2 3s together, or 33. Okay? Does that make sense so far?
Wait, hold
Okay.
on. I have a question. So the first 3, which is from x array 0, is because the previous answer was 3 as well, right? Oh no, the previous answer was 4, right?
Right. This answer was 4. This answer. So the reason why this is the first one is 3 is because of this line of code right here. A of x comma y. You go to the function a, and you see x sub 0 is now being replaced by the whatever the value of the second parameter is. Now the thing is, if you guys didn't know this, now you do. Arrays are always pass by reference. What that means is, do we change because exactly. So that's why we change it. Arrays are always passed by reference. So pass by reference means you're changing it in the main function as well. You're not just changing it in the function you're currently in. You're changing it everywhere. Does that make sense?
Yeah, thank you.
No problem. Okay. Great. So does anybody have any more questions about this question, or should we move on to writing entire recursive functions by ourselves? Okay, perfect. Mike, can you stop sharing your screen? Perfect. Let me go to document. Okay, I'm going to share my screen right now. Okay. You guys can see my screen, right? Easy example. So recursion, I wish there was an easy example. I mean, there is one. I can make it up if you'd like. Okay, I'll make up an easy example. I actually have one in mind, and then hopefully you'll understand the idea of recursion if you don't already. But recursion, just to put it out there, is a particularly harder topic that they teach. And not many students get it the first time. Usually you'll get it by the time you either finish a 200 level class or start a 300 level class. But just understand that it's not something that if you don't understand that you should beat yourself up on. So here's an example, easy example of recursion. Okay, so does everybody know what a factorial is? No. Okay, so let me go over factorial really quickly. Factorial means you start off, say I give you, here's an example, 5 factorial. This exclamation point means factorial. So say we start off with 5 factorial. Factorial means take that 5 and multiply by one number less. Then take that 4 and multiply by one number less, the 3 by one number less, the 2 by one number less, up until you hit 1. Exactly. So the formula is n, which is what we started with, times n minus 1 times n minus 2, ... up until we get to 1. Okay? That's the formula. And then these are all multiplying each other, obviously. So this, I believe, should be 120. Let me see that. 6, 24. 24 times 5 is 120. Yeah, okay. Yeah, 0 factorial equals 1, which is actually important. Okay, so let's say, I'm going to tell you 0 factorial equals 1 and 1 factorial equals 1. Okay, this is something that the teacher should tell you at the beginning of the question. So so now we're going to write the recursive function for factorial. And let's do it. So what am I returning? What's my return type? Integer. Excellent. Good. Int, and we can call this factorial, doesn't matter. And how many parameters do I take, and what is their type? Good. One int, we'll say int, I used n, so let's use n. You can use whatever letter you want, it doesn't matter. Good. So now, I have to have what's known as a base case, right? That means once my recursive case stops working, it falls back onto my base case. So somebody mentioned it before in the chat. 0 factorial equals 1 and 1 factorial equals 1. So we say if n equals 0 or n equals 1, we return 1, right? That's just our base case. What do I do? Somebody tell me the recursive case. So this is my base case. What is my recursive case? If somebody take a shot at it. No, so we're assuming positive numbers. It's if you have a negative number, if you have a negative number, say you have -5, multiply that by -6, multiply by -7, multiply by -8, multiply by -9, you go up until -infinity, which means you're going to be in some sort of loop infinitely. Let's see. So we just assume positive. Okay, Josh, you're close. You're close. If I say factorial, well, first we have to say return, right? Because that's what we want. We want to return something. So I'm going to put a little space there. Factorial of n minus 1. Good. You got it, because not n divided by 10. We're still missing one piece. But the idea is, this portion at least, is I'm subtracting 1 from my previous term, which is excellent. N times. Excellent. Okay. I'm doing two things. I'm subtracting 1 from the previous term, but I'm also multiplying that term by whatever the next following term would be. So here I have 5. I multiply that by 1 less than 5. Okay. And so let's run this program. Let's say I put in 3, just to make it a little easier. So I have factorial. I'm going to abbreviate that to fact. Factorial of 3. So it doesn't pass my base case. So I go return 3 times factorial of 2. Factorial of 2 doesn't pass my base case. Let me just write factorial of 2. So factorial of 2 doesn't pass my base case. So I still have the 3 times. And now factorial of 2 turns to being 2 times factorial of 1. Right? Now factorial of 1 does pass my base case. It's 1. But I can't forget about the 2 that was multiplying it before, and the 3 that was multiplying that before. So 2 times 3 times 1 is 6. And 3 factorial, if we try it out, 3 times 2 times 1 will be 6. Okay, does that make sense to everybody? We can go through it with the one more just to make sure it's concrete. We'll do 6 this time. We'll do a little bit of a bigger number. And I'm telling you the answer should be 720. Okay, 6 factorial is 6 times 5, which is 30, times 4, which is 120, times 3, which is 360, times 2, which is 720, times 1, which is the same. Okay, So let's do this. This is 6. This equals 720. Factorial of 6. So I can't do anything, but I do 6 times factorial of 5. I can't do anything with factorial of 5, so I do 5 times factorial of 4. Can't do anything with factorial of 4, so I do 4 times factorial of 3. Can't do anything with factorial of 3, so I do 3 times factorial of 2. Can't do anything with that, so I do 2 times factorial of 1. This I can do something, it returns 1. So what that means, I don't understand what you mean by n minus 2. So what that means over here is I plug in the 1 to this one, so I have 2 times 1, which is 2. Now, the whole thing, 2, gets plugged into this one. So 3 times 2, 6. The whole thing gets plugged into factorial of 3, and this is 4 times 6, which is 24. The whole thing gets plugged into factorial of factorial of 4, so I have 5 times 24, which is 120. I have 120 being plugged in. Oops. Yeah, I have 120 being plugged into factorial of 5. I multiply that by 6. This equals 720, and I reach the top of my tree. So 720 equals factorial of 6. Can we do another one of this? Yeah, I have a bunch of these examples. I have a bunch of these examples that we can go through. The examples that I have are previous test questions. So don't assume that you guys are going to have something as easy as this on your exam. I just wanted to give you this example so that you have a good base of what recursion is.
Okay, sorry, can I ask you something?
Yeah,
Can I
sure.
ask a question? Okay, so I didn't get it because I thought we're following this formula or something like n, then n minus 1, then n minus 2 that you put.
This
Second
formula
line,
over here.
the second line, yeah. So I
So,
thought we're using that.
so this is the mathematical formula. And
This,
so when with coding, you have to translate that into code. Okay.
okay.
So in code, you could use a while loop, right? And what you can do is you can say, if you don't want to do a recursive one, you want to say like while n is greater than 1, you're gonna do n. We have to have a product. So let's say we have a product, int prod equals 1. You're gonna do product times n, and then you're gonna say n minus minus. We're gonna subtract 1 from n, and we're gonna keep doing that until n is less than 1. So say n is 4. Okay, we do 1 times 4. Sorry, this should be product times equals. Let me change that. Good. So now product is 4 and n is 3. So now let's change this to 3. And this we also have to change. So now we do product, which is 4. We multiply that by 3. And then we subtract 1 from n. So this is 2, and product is 12. So let's change that over here. That's 12. Now, n is 2. So we have to change that. 2. So we have product, which is 12, times 2. That's 24. We have to change that over here. 24. And n is 1. N is 1. Now we go out of the while loop because this is false, and we can say C out product. which would give us 24. And that's what 4 factorial is. Since it returns 1, n times 1, where n represents the number, we get exactly, yes, MD. Good. So that would be the code if you did it iteratively using this formula up here. The problem is she wants you to do it recursively on the test. So you have to think like 3 steps ahead. Does that make sense? Okay. I'm gonna assume it does for whoever asked that. Okay, so do you guys want to move on to, okay, perfect. Do you guys want to move on to a test question that I have here? Okay, let's do it. So this is one of the previous test questions that she gave on an old midterm, I guess. So we're writing a function. It's called starts with. The function has 2 integer parameters, okay? Does anyone have an example of Akinlar's second exam? The function has 2 integer parameters that are both positive. It determines whether the second number starts with the first number. For example, 19683 starts with 196 and with 19683, but does not start with 197 or with 19683. Okay, so it determines whether the second number starts with the first number. Fine. Okay. Your function can return any answer of your choice in case either parameter is not positive. Okay. Excessively long solutions that use more than 8 lines of code may lose points. Okay, let's do it. So, what's my return type here? Not int, bool. Excellent. Because I see true, true, and false as statements, so it's bool. Good. Boolean, and they call this function starts with. And they told us it takes 2 integer parameters over here. So int A, int B. And we're checking whether the second number starts with the first number. Okay. So, and we have to do this recursively also. So, if, let's think of some base cases. Okay, so we see this. There are 2 things that we see. Does this second number start with the first? Does the second number starts with what the first number starts? I'm a little confused, MD. Does the second number start with? Oh, what does the second number start? Okay, let me give you an example. The second number here is 747. It starts with a 7. 74 starts with 74, but 74 does not start with 747. That's what they mean. So here's another example. 5 and 547. These are good. 74 and 92 are not good. If I do 953 and 9531, these are good because it starts with it. Okay, does that make sense so far? Okay, great. So now we see 2 things. We see, for our base case, we see that if the first number is greater than the second number, it's automatically false. Okay, we see that. If the first number is greater than the second number, sorry, that's not it. I can do 95317 and 953. 953 cannot start with 95317. It's just not possible. So we see if the first number is greater than the second number, or no, that's it, just that one, sorry. That's one of our base cases. Okay. So if the first, so how do I say that in code? Does anybody want to try it out? How do I say if the first number is greater than the second number? Excellent, good. We used A and B, but good. So if A is greater than B, return false. Excellent, good. And then let me just put the title line we created. It was bool starts with, we said int A, int B. Excellent, okay. Okay, so we said if A is greater than B, return false. Great. Now, what else do I see? I see if the two numbers are equal to each other, then it's automatically true. Automatically. So let's write that down. If A equals B, right? If the two numbers are the same, that's automatically true. So these are our base cases, okay? And the reason why I don't say good MD, the reason why I don't say else if is because these two are mutually exclusive. You can't be the same value and greater than the second value. It's not possible. So now we have to do our recursive case, okay? So our recursive case is always return. There could be something before, just like we saw with factorial, and there could be something with after. But let's see what we have to do here. Okay, let's take this example. 7 and 747. Okay, what do I have to do to the second number to see if it matches the first number? The amount of first digits match the first number. What do I have to continuously do? Not mod by 10. Divide. Excellent. I have to divide by 10. And after every time I divide, I check to see if the two match each other. So let me put that example over here. 7 and 747. Excellent. So what I do is I divide by 10 and then I check. Is one greater than it? No, this still isn't. Are they equal to each other? No. So I do my return statement again and I remove another digit. Now I check, is one greater than the other? No. Are they equal to each other? Yes. So I return true. Okay. So to say that in code, we say return starts with, and all I do is I still give in the same first parameter, but like you guys said, divide by 10 the second parameter. And this is considered easy on the exam. Okay. Does everybody understand this one, or should I go over it again before we move on?
Can I see the question again?
Sorry?
Can I see the question again? I'm still confused what they mean by the second number start with the first number.
So they mean the second parameter, if that makes it a little clearer. They're saying here 7 and let's do 758. Okay. Does this second number start with a 7?
Yeah, to start with a 7 in the first digit.
Yeah, in the first digit. That's what we mean when we say starts with, right? If I give you this number, what does this number start with?
1.
1, exactly. When we say starts with, we mean from the leftmost side. Okay, I see somebody's asking. Okay, let me go over it one more time because some people are asking for it. So You know what? Let me ask more specifically. Which part do you want me to go over? The base cases or the recursive case?
I'm still confused with why the last one is false, 747 and 74.
Because can 74 start with 747?
No.
No, 74 can only start with a max of 74. Does that make more sense?
But they both have the same third digit.
But that's not what we're checking. We're not saying that these two are interchangeable. We're checking to see whether the second one starts with the first one. And if the first one is greater than the second one, then it's automatically false.
Oh, I see. 7 is greater than 4.
Exactly. You can think of it as placeholders. Like that. If the second, and this is the first, and this is the second. If the first one is bigger, this here is technically nothing. This would really be like a 0.0. If the first one is bigger than the second one, it's no good. That's just part of the rules.
I got it now.
Okay, perfect. Okay, let's do another one, and if people don't understand that one, then we'll see what goes. Okay, let me see if this one is. Sorry, give me 1 second. My thing is acting up. Give me 1 second. Okay, can you guys see my screen again? Okay, so I was going mic. Okay, perfect. Okay, question 31. Let me see if this one is a recursive one. Some diff. No, this one isn't a recursive one. Let me find another one. Which one is this one? This one is 32. Is 32 a recursive one? Write a function called display. The function has one integer. Okay, do you guys want to do this one? Okay, let's do it. So we're creating a function called display, and when I only print something to the screen, it's called a void. I'm not returning anything. So void display, and let's see what I'm returning. So the function has an integer parameter that is positive. Okay, so it automatically has to be positive. We just assume that. So we'll say int a. Okay, it prints a diagram with horizontal bars to display the digit of the parameter starting from the first digit at the top. Okay, each bar should show numbers that count from 1 to the digit being displayed. Oh, I see. Okay, fine, I see. Let me give you guys another example just so you have it. If I say display of 3, 2, 7, it would do this. It would do 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay? Essentially what you're doing is if the first digit is a 3, you're counting from 1 up until 3. If the second digit is a 2, you're counting from 1 up until 2. The next digit is a 7, so you're counting from 1 up until 7. Okay? And so that's what we're doing here. We're counting up until 3, 1, then 4, then 1, then 5. Okay? The last digit should be part of the digits in the parameter. So now let's take a look at how to write this with our base cases. Let me just erase all of this. Okay. So, good. Our title line is good. Void display and okay. So if there's somebody give me a base case. What do you think the base case would be? No. Excellent. Good. If A, and we're assuming that it's positive, but it wouldn't hurt to say this. If A is less than or equal to 0, return not A, we're returning 0. Good. Sorry, not return 0, just return. Sorry, just return. Remember, void functions don't have a return value associated. You can just say the word return and that's fine. Okay, I think we saw that in one of the code output questions. We said return and it just went back to the main function. Nothing else. Okay. Now, I want to print the last digit at the bottom and the first digit at the top. Is it wrong? Yeah. It is wrong to return 0 because that would only be appropriate if the return type was an int. But in this case, it can't be an int because we're not returning only one number. We're returning sort of a display, an array of numbers. Okay, good. So what would I have to do? I want to return the first digit. Okay, so let's see what I do. I want to first print out the first digit, right? This first digit. I want to print out up until 3. So I have to do what to the rest of the digits? Excellent. Good. I have to remove the last digit. And the way to remove the last digit is dividing by 10. Excellent. Good. Now, once I remove the last digit and up till the first digit, I want to print the values up until that digit. So we use a loop, right? That makes sense. If I want to print out numbers 1, 2, 3, and I give you the input 3, I start my loop at I equals 1, and then I go up until the value I give, which is 3. So we're going to say for int I equals 1, I is less than, at this point it would be A mod 10. Okay, that's important. And then we're doing I plus plus. And then all I print out is I, right? The value I'm currently at. And then what I want to do, so when I'm done with that for loop, I printed out 1, 2, 3, for example. I want to go to a new line. So I just say cout endl. And this closes out the function display. Okay. What's with the I less? Okay, so that's the condition. This is my condition. And we have that there because say I have the digit 4. I want to print out 1, 2, 3, 4. How do I know 4? Exactly. Yes. Good. Okay, fine. Glad that was able to help. Why do we put n divided by 10? Because we want to print the first digit out first. So 3, 1, 4, 1, 5. We delete the rest of the digits. 3. This is how it works. Let me show you. Display of 3, 1, 4, 1, 5. Then we delete the other digit. We do display 3, 1, 4, 1. We do display. We take the last digit off. 3, 1, 4. Display 31. Display of 3. And then you do display of 0. Right? Yeah, 0. And so what that does, this is our base case. And so we return to where it was called from. Our base case was called from display of 3. So then we run display of 3 from where we left off. We already ran this line, so now we have to run this line. And so we do the for loop and we get 1, 2, 3. Great, this returns 1, 2, 3 and a new line. So that's how we get this 1, 2, 3. Good, this was complete. Now we do of 31, but we already did the one of 3, which added 1, 2, 3. Now we do the part with the 1. So that just gives us the 1. And we do that consecutively. 1, 2, 3, 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, 5. You guys can't see that so well. Okay, now, I think you guys have 4 questions on your test. Each one is worth 10 points. Just to break down how the point percentages will work. Recursion, if it's the same. Oh, you guys have 5 questions. Okay, so is it worth 50 points? I forgot, honestly, but the way that mine worked is if you got the title line, that was 1 point. The base case was another 2 points. That's 3, or no, maybe it was 2 points and 2 points. And then there was the recursive case was split up into 2 sections. Random number generator, program design. Okay, so your recursion might be a little different than mine, than how mine was. Okay, fine. So never mind. Forget what I said. And if we wanted to start from last top, what we do? Yes, correct.
I have a question.
Yeah, what's up?
Why did you use the void function?
Void, because whenever
Yes.
we print something to the screen, we use void, right? These are usually cases when to use void. So if you're swapping something, you're probably using void. If you're printing to the screen, right here, I'm just printing to the screen a picture. That's using void. If I want to say, I don't know, if I print to the screen, exchange. Let me see if I have my list here. Yeah, print void, swap void, exchange void. Oh, if you want to set something, right, that's also a void. If I just want to set x equal to a, I'm not returning anything. I just want to set it. And so that would be a void as well. Now, the reason why this isn't an integer, if you're thinking that, is because I'm not returning one integer, I'm returning an entire picture. Can we do a recursive problem? We're actually out of time now, I think. Let me see really quickly. If we are, let's see. Okay, give me one sec. Somebody asked me a question. Can you explain how it starts from the first number? Yeah, so we continuously divide by 10, and dividing by 10, I'm sure you remember from your first test, just gets rid of the last digit. So continuously doing that over here, this gets rid of the last digit. And once we reach our base case, then we can get to the rest of the code. Yes, this was the, question number. This was question number 32. Yeah, the recording will probably be up either later tonight, I would say around 6 or 7 on the Learning Commons website, or it would be posted at latest tomorrow. And if everybody could just fill out that feedback form so we can get funding to do this for the final, that would be really appreciated. And I can stay on for a couple more minutes if you guys have some last minute questions. Let me just stop the recording really quickly.